Hello and welcome to the last lecture of this first unit, the third lecture on the series of quadratic expression. In this one, we're going to be looking at quadratic inequality. So first, let's see what is a quadratic inequality. So a quadratic inequality is an inequality of the type ax squared plus bx plus c above 0 or above or equal to 0 or smaller than 0 or smaller than or equal to 0. Okay, it is just an inequality with a quadratic term. The way to solve this kind of inequality is different than the way to solve a regular inequality. For example, 3x plus 2 positive. You just do some simple algebra there. You play with the properties of inequality. You subtract 2 from both sides and you get 3x above negative 2, and then you divide both sides by 3x above negative 2/3. So this is just playing with the property of inequality. It doesn't work like that with quadratic inequality. You don't play with properties of inequality. The first thing that you want is having a 0 on one side. So to explain how it works, let's just go over an example. So suppose I want to solve the inequality x squared plus 2x smaller than 15. The first thing I have to do is move my 15 on the other side of the inequality. So I have x squared plus 2x minus 15 smaller than 0. Then I'm going to try to factor. Now we're lucky for this one because it factors. If it doesn't factor, we're going to have another method, okay? So let me factor this one. So it is x, and we want a plus 2, so it's going to be plus 5 minus 3, right? And x minus 3, product negative 15, sum plus 2, smaller than 0. Now I know when a product of two factor is negative. So what do we need? We need x plus 5 negative, and at the same time we need x minus 3 positive, or I need x plus 5 positive and I need x minus 3 negative. There are no other cases, so this is an and right here. So there are two possibilities, right? And there are no other cases where the product is going to be negative. So let's pick it up. What's the first one? X plus 5 negative means x smaller than negative 5 and x above 3. How can you have x smaller than negative 5 and x above 3? You can't have that, right? So that's the empty set right there. Okay, this amounts to the empty set. Now let's pick up our disjunction. Or what about the second one? This is x above negative 5 and x smaller than 3. Now that makes sense. Above negative 5 and smaller than 3. So basically I'm between negative 5 and 3 right there, right? So the interval solution is negative 5 and 3. All right, now there is a better way to handle this kind of inequality. We're gonna do a sign chart. Okay, so what is a sign chart? Again, we want to solve the inequality x minus 3 times x plus 5 smaller than 0. Let's look at the factor x minus 3. Okay, so in my sign chart, I'm going to have my first row. This is the row where all the values of x's are. Right here, it's all the values of x's. So it goes from negative infinity to positive infinity. Okay, and then in the first column, I'm going to write the factors. So here, suppose I want to study x minus 3. All right, so where is x minus 3 equal to 0? At x equals 3. It's a number I'm going to write in the row right here. This is a real line, basically. This right here is the real line. Okay, this is the entire real line. So I'm going to draw a line right under 3, not next to it, right under 3. And then I'm going to express in this table the sign of x minus 3. First of all, x minus 3 is equal to 0 if x is 0, x minus 3 is equal to 0. If x is here, right here, x minus 3 is positive, right? X is above 3 right here, so x minus 3 is positive. And if x is here in this column right here, which means between negative infinity and 3, x minus 3 is negative. This is a sign chart, and it explains the sign of x minus 3. Okay, now I can do the same thing with the other factor. Okay, here's the real line right there from negative infinity to positive infinity. I'm going to write x plus 5 here, okay? And in the middle of the line, I'm going to put negative 5, because this is where x plus 5 is equal to 0. I'm going to draw a line right under. In this case, if x is above negative 5, x plus 5 is positive. Oop, this one disappeared. Then it's negative below, and it's 0 right there, okay? So this is a sign chart, but this is very simplistic. Let me represent the sign chart where I'm going to be studying this product here. So here we go. We're going to put these two charts together now, okay? And this is the one that you have to do. You don't do these two right there. You do this one. So x again goes from negative infinity to infinity, right? The different factors, I have two factors, x minus 3 and x plus 5. So x minus 3 and x plus 5, right? All right, so there will be two rows right here. These are my two factors. And then finally, there is the expression I want to study. The expression I want to study is x squared plus 2x minus 15, right? Remember our inequality here. I'll write it here. We wanted to study x squared plus 2x minus 15 negative. We wanted to know where that is negative. All right. In my top row, right here on my top row, I'm going to write the two value that will make my factors, my two factors equal to 0. So I need to write a 3 right there and a negative 5, right? Okay. So don't forget this is a real line, so we have to write them in order, negative 5 and 3. Here we go. And then I'm going to fill this sign chart with sign. X minus 3 is equal to 0 when x is 3, x minus 3 is equal to 0. When x is negative 5, x plus 5 is equal to 0. If x is above 3, x minus 3 is positive, and it's negative below. If x is above negative 5, right there, x plus 5 is positive, and it's negative below. Okay, so far so good. I've put these two sign chart right here together in the big one. And now what's going on? Now this expression is the product of the two right here. And I know the rule for the product of two signs. If you multiply two negative, you're going to find a positive. If you multiply two opposite signs, you're going to find a negative. And if you multiply two same signs, you're going to find a positive. Then the expression will be 0 at 3 and 0 at negative 5. Therefore now it is very easy for me to see where this is negative. Negative means a negative sign. It's negative right here. Where is right here? Between negative 5 and 3. So I can read directly in my sign chart, the solution is negative 5 and 3. Okay? This is very quick if you can factor your expression. Let's go over an example from my notes. Alright, number 1, how do you solve this inequality? So the first thing is we're going to move the 2 on the other side. 6x squared minus x minus 2 is negative. Second, this one will factor, so this is very nice. 3x minus 2 times 2x plus 1, right? You got a minus 2, and then minus 4 plus 3 is minus 1, yeah? Negative. And then finally, I'm going to do my sign chart. So here's my first row of all the possible values for x right here. Okay, it goes from negative infinity to positive infinity. I'm going to write my factors here. 3x minus 2. The other factor is 2x plus 1. And finally, I'm going to write my quadratic expression, 6x squared minus x minus 2. Here we go. On the top row, I'm going to write all the values that will make all the factors equal to 0. So what do I have? I'm going to have a 2/3 from this one and a negative 1/2 from this one. So here we go. Negative 1/2 and 2/3. All right. Now, it is very important to draw the line right below the numbers, okay? Sometimes students put it next to it, and then it's difficult to read and understand the answer, okay? Right below the number, right here. And now let's start filling the chart. 3x minus 2. All right, so it is equal to 0 at 2/3. And then it is positive where? 3x minus 2, if you're not sure where it's positive, just solve this simple inequality. 3x above 2, x above 2/3. It's positive when x is above 2/3, and it's negative before, okay? How about 2x plus 1? 2x plus 1 is equal to 0 if x is negative 1/2, and then it's positive after negative 1/2 and negative before. Okay, another way, instead of doing this right here, another way to understand that, guys, and this is what I'm about to show you with the next method for solving a quadratic inequality, something a little bit more graphical. It's going to be much faster. So think of the line 2x plus 1, right? The slope is positive, so the line is going up, and therefore 2x plus 1, which is y, is above 0 if x is past 1/2, and it's negative, it's below 0, so this is what I'm expressing right here. Above 0 when x is past negative 1/2, and below 0 before negative 1/2. Okay? Alright, so now let's multiply the sign. We got a plus, a minus, and a plus. And again, I wanted to solve for negative. You realize that if you have an equality right here, let me put an equality right there, okay? It's equal to 0 here, then the solution set with the equality would be negative 1/2 to 2/3, okay? Depending if you are taking the boundaries in or leaving them out, all right? Okay, now what happens if you cannot factor your quadratic expression? Let's go over the other method for solving a quadratic inequality. You will see it is faster and it's more visual at the same time. So suppose now that I want to solve this inequality right here. It does not factor. So I'm going to have another kind of approach. I cannot do a sign chart. You remember, in the sign chart you have to write the different factors. This approach that I'm about to show you also works when you can factor the expression, and actually it may be even better. It's a very fast approach. I like it. It's the way I normally solve inequality. But please don't discard entirely sign charts. We're gonna see them again. They will be very useful when we want to solve other types of more complicated inequalities. Okay? Alright, so how do we do this? Well, hey, we give it a name. We call it y. This we call it y. So it is 2y equals 2x squared plus x minus 2. And I know the shape of this. It's a parabola. And I know it's also concave up. There are three possibilities. Maybe it won't touch the x-axis. Maybe it's going to touch it at 1 point. Or maybe it's going to touch it at 2 points, right? These are the possibilities. In any case, once I visualize what kind of parabola I have, I should be able to solve. In this case right here, in the first case, when it doesn't touch the axis, it's always positive. My y are always positive, so everything would be a solution. In the second case right here, it's always positive except for this value right there. So you would have to remove this value where it's equal to 0, right? And in the third case, well, in the third case, it's positive outside the roots right here, and here it's positive too, but inside the roots it would be negative. Alright, so I can solve the inequality. I just need to figure out the x-intercept, and that's the first thing I do when I'm given a quadratic equation. I'm looking for my x-intercept. So x equals negative 1 plus or minus, so b squared, so that's 1, minus 4 times a times c, alright, over 2a, 4. So what do we have? We have negative 1 plus or minus square root of, that's 16, 17, over 4. Let's quickly check the graph of this. So one of the roots, square root of 17 is about 4 point something, right? So one of the root is 4 minus 1, 3, 3, 4, so it's going to be like right there. You don't have to do a very precise graph, it doesn't matter, right? And the other one is negative 4 minus 1, negative 5 divided by 4, negative 1.25. So if negative 1 is right here, it's going to be a little bit past right there. And we said it's concave up, so here's the kind of graph we're dealing with, concave up, okay? And you can see it is going to be positive outside the root, right there and right there. By it, I mean y, right? We decided to call it y. The whole thing is positive. That means y is positive. Y is positive here and here, okay? Between the roots, y is negative, right? It's all negative. Okay, so what do we want to solve? Strictly above 0. Therefore, the solution set to this inequality is negative infinity to negative 1 minus root 17 over 4. Or, that's a union, 1, negative 1 plus root 17 over 4, infinity. That's it. That's how I solve an inequality when I cannot factor. And even when I can factor, it's even easier, okay, because you wouldn't have to use a quadratic formula. Even when I can factor, I like to have a graphical reasoning. Let's go over another example. So I will do 3 and 6, and you do 4 and 5. Okay, well, this right here will not factor. Therefore, right away, I'm going to be looking for the x-intercept. So x equals negative b, so 1 plus or minus b squared 1 minus 4 times 1 times negative 5. Don't make a mistake with the quadratic formula, please. So what do we have? We have 1 plus or minus square root, so that's 21, over 2. The parabola is concave up, alright, so I do have two roots. I don't care where they are. Basically, I don't even have to draw the y-axis. I don't care where they are. Concave up, two roots, and I want to know where it's negative or equal to 0. So it's going to be between the roots. So here we go. The solutions are 1 minus root 21 over 2, 1 plus root 21 over 2. You see that? This is super fast. Okay, I'm going to do 6. And you do the other two, okay? All right, number 6. Oh, another one that is concave up. So what do we have here? We have x squared plus 6x minus 5 is smaller than 0. Oh, unfortunately, it does not factor. If I had a plus 5, it would have factored nicely, but this one does not factor. So let's get the x-intercept. The x-intercept are x equals negative b plus or minus b squared minus 4ac, so b squared 36 minus 4 times 1 times negative 5 over 2. So it is negative 6 plus or minus 36 and 20, 56 over 2. Any square in 56? Yes, there is a 4. 56 is 14 times 4. So let's take a 2 out. So it's negative 6 plus or minus 2 root 14 over 2. And so it is negative 3 plus or minus root 14. What did I want to solve? Negative. The parabola is concave up. It's going to be strictly negative between, right here where y is negative, between the roots. So the solution set is negative 3 minus root 14. Negative 3 plus root 14. Okay? So, I hope this is clear. This is just a technique to solve quadratic inequality. And this concludes the first unit. Thank you for watching.